And so the phone on the left is actually running essentially the end user update that'll actually go out. And if I click, I'm going to try to do this as, do you want me to do it at the same? Okay. Let's see if I clicked them both. You'll see the performance. And this is a really common game. It's Bejeweled. If people play it, I'm totally addicted to it.
So what did you do to get the performance improvements?
There's
Don't
a number.
Say secret sauce. You're not allowed to say secret sauce.
Totally comfortable saying secret sauce with you, by the way. There's a number of things we actually did to improve it. The number one thing is actually change how we actually manage memory. And so the nice part about that is essentially every single app, without having to do anything differently, will actually benefit from the performance improvement.
So how did you manage memory before versus how you're doing it now?
Well, it was really a function of like how much we would allow you to preload in a serial or non-serialized way. So the apps that are going to benefit the most are going to be apps that preload a lot of graphics. Right? And so,
now preload before you're tapping or before like the minute you tap?
So like if you look at...
Oh, I understand. So by the time you hit it, it's preloading.
Why Bejeweled is such a good example is they're actually loading all the game pieces and game boards into memory.
Okay.
Right? And so when we open up that threshold, essentially, more of that can happen.
Okay. So it's not necessarily the latency to app start, it's the latency to playable.
Yeah, we don't actually have any challenges with the app start. It's really getting memory moving. And then there's a lot of apps that don't benefit at all, primarily because the graphic component isn't a huge one. Like Flickster is a really good example where it's mostly pulling data from the web.
Yeah.
And so the app loads reasonably well. While there's a small performance improvement, it's not noticeable. And you're still waiting for the app because it's the pipe that's the challenge. But mostly the games, especially the XNA games.
So what was the limitation before? You had a size limit on how much you could preload?
Yeah, well, at one given time. So we basically take chunks from you. And then we would try to load as much as possible, and we were waiting.
Because remember, some of these are Flash, and some of them are SD.
One more time.
Is this disk I/O related? Because some of them are Flash and some of them are micro SD inside.
In fact, we actually treat all the memory as a flat piece of memory.
It sounds like it's a construct issue.
It's totally a construct issue. And so it was feedback we got from developers. We definitely heard it from early end users.
Wow, that's way faster.
Oh, it's night and day.
But what was the initial motivation to limit it to whatever chunk size you had before? Was it a power efficiency thing? Like, what's the downside?
I mean, the trade-off.
Yeah.
I don't really know. I think it was more of a question of like trying to think about how apps would need or want to load.
Okay.
And you do that in isolation initially when you're building a platform, right?
Yeah.
Like you have a bunch of software developers thinking, well, if I wrote an app, how would I do it? And then I think you look at what actually takes place.
Yeah.
Operating system developers are quite different than game developers. And they think fundamentally differently.
Yes,
especially game developers, a lot of our game developers are coming from the console. And so they're used to very, very vast resources. And it's much harder to bring that to the phone and manage memory space and those types of things differently.
So other than the memory management and copy-paste, are there any other under-the-hood enhancements?
Yeah, but I would probably put them more in the minor category.
Okay.
There's a lot of things that we saw based upon rolling the product out, and they were, in most cases, I don't